Good morning students. In last class we started lesson 9th standard unit 2 motion, and we have discussed about motion and the types: uniform motion, non-uniform motion, distance, displacement, speed, velocity, acceleration. So these are the topic we have discussed in the last class. Now we are going to discuss about distance time graph for uniform motion and distance time graph for non-uniform motion. As you know very well, what is the meaning of uniform motion that we have discussed in the last class? Okay, uniform motion is nothing but equal distance should be covered by the equal interval of time, right? So equal interval of time, equal distance covered is called as uniform motion. What is called non-uniform motion? It's very simple. It's just opposite. Equal interval of time but unequal distance is covered. Unequal distance covered is called as non-uniform motion that we have seen in the last class. Now we are going to draw a graph for the particular points. For example, time. Time is taken in minutes, distance taken in a meter. For example, it started with time 0 and the distance covered is 0, and the time when it's 5 minutes, the distance covered is 500 meter. And 10 minutes 1000 meter, 15 minutes 1500, 20 minutes 2000, 25 minutes 2500 meter. When you look at the reading itself, we can find out easily that is equal time interval, equal distance is covered, correct? So equal interval of time, that equal distance is covered, that is called as uniform motion. Let me plot the points here. For example, x-axis has taken as time, that is in minute, and y-axis is taken as distance, that is in meter. Okay, that should be mentioned. And x-axis, y-axis, distance, time. Okay, just you take the points 5, 10, 15, 20, 25 in x-axis, and 500, 1000, 1500, 2000, and 2500 in y-axis. Okay, so when you join all the points, you will get a line that is in a straight line, right? And when the line is straight, that means there is no variation in the speed and time. They are going in smooth way, which means they are in uniform motion, right? For example, you just point out one small point, that is A, B, C. You take this triangle. So here that AB is nothing but the time and BC is nothing but distance. As you know very well, using this graph, what is the use of this graph? It's very simple. We can find out the speed. Okay, the speed that we are traveling, we can easily find out with the help of the diagram. So let me take speed formula, that is distance covered by time taken, right? So distance covered is nothing but, what is the distance covered here? For example, point BC we have taken. So the BC, the distance is 500 meter, right? So BC 500, and the time taken, that is the difference between these two, that is 5. So 500 divided by 5, just cancel and you will get 100 meter per minute. Okay, so in all the places we are traveling with the same speed of, what is that speed? That speed is nothing but 100 meter per minute. Okay, 100 meter per minute, right? So you look at another diagram, that is diagram number 2. You just look at here. So what's happening here? Is it uniform motion or non-uniform motion? Yes, of course this is uniform motion because walking, cycling and moving in a car. Okay, going by walk, cycling and moving in a car all goes in a straight line, right? This walking goes in a straight line, cycling goes in a straight line, and car goes in a straight line. What's happening actually here? When this line goes deeper into deeper, what will happen? Which means it is very fast. This is medium and this is slow. But they are going and covering equal interval of time with the equal distance. They are covering equal interval of time with equal distance. So this is called as uniform motion. But the speed varies. That's it. But they are in uniform motion. Understand? So uniform motion, we know the meaning. We have taken distance time graph and we have the points. You plot the point and you take one small triangle, which means that is A, B, C, so that we can easily find out the speed from the graph, right? So speed formula, we know distance by time. So distance is 500, time is 5 minutes. You just cancel it, you will get 100 meter per minute. That is called as speed. So in each place they are covering with the speed of 100 meter per minute. Okay, what's happening here in the second case, that is distance time graph, that is in non-uniform motion. Why do we call it as non-uniform motion? It's because the time, this is distance, right? So as we have taken in the first case, we also take the same way, because we should not change the time interval. Time interval should be equal in all the cases. Okay, for example, here we have taken the equal interval of time, that is 0, 2, 4, 6, 8. Equal interval of time. For example, these two difference is 2 minutes. These two difference is 2 minutes. These two difference is 2 minutes. 6 to 8 difference is 2 minutes. That is called as equal interval of time. But distance is covered is not equal, right? So here the distance covered is 2 meter. Here the distance covered is 4 meter. The difference here 2 meter. Again here 4 meter. So there is a change in the covering up the speed, right? So just take out the points in the time x-axis, y the distance should be taken, and plot the points, and you can see that in the graph we will not get a straight line, right? There is a change in the straight line. So this is called as non-uniform motion. When the line is not in straight line, that is called as non-uniform motion. So this is very important. Okay, so you have to know about only that uniform and non-uniform using the graph. So from the graph I can easily find out what is that the speed. What is the speed between one point to another point? We can easily point out and get the answer. Topic, that is velocity time graph, right? So velocity time graph, as you know, what is the meaning of velocity? Velocity is nothing but rate of change of displacement that we have seen in the first session. So velocity is nothing but rate of change of displacement. So velocity is equal to displacement time. This can be written. So I just want to find out the displacement. I can easily find out the time should be taken the other side. So displacement is equal to velocity into time. So displacement can be mentioned in the letter, that is S. You can call it as displacement or distance covered is equal to velocity into time. So here we are going to use the velocity time graph. We are going to find out the displacement, right? Using velocity time graph, we can find out the displacement, how much distance that object, the car is covered, right? So we can calculate. For example, you just see the graph. So in x-axis time is taken and y-axis the velocity is taken. So time is taken in hour, the velocity taken in a kilometer per hour. Okay, so 10, 20, 30, 40. Now you look at the diagram, the graph, that velocity is taken, that is in 40 km per hour. So if that constant velocity is maintained, that is 40 km per hour. So draw the diagram. I can find out the displacement of the car. For example, what is the displacement between one point to another point? I have taken the 2 points between A and B, right? You just cover that all the places. The time interval between T1 and T2, that should be maintained, right? So between time and these 2 points, what is the distance covered? From 2 to 4. Okay, 4 hours, what is the distance is covered? I can easily calculate, that is distance covered is equal to, or else we can call it as displacement, right? So distance covered or displacement is equal to velocity into time. So velocity, that will be in y-axis and time in x-axis. So velocity, this is what is that, A and C. So A and C is called as velocity, that is in y-axis, and time, that is in x-axis, that is nothing but C and D. When you multiply these two, and you will get that area of the particular place that covered, right? That area covered we can calculate, that S is equal to area of rectangle, that is A, B, C, D we can calculate. So the total area covered that we can calculate with S is equal to AC into CD, that is nothing but the product of velocity and time, right? That's called as displacement. The total displacement of the car we can calculate in any point we can calculate. That is the use of velocity time graph. Okay, in the second graph what we are going to learn, that is uniformly accelerated motion. Uniformly accelerated motion. Here also we have taken the time in x-axis and velocity in y-axis. So now after drawing that graph, we just take 2 point, that is, which means that velocity is going in a uniform motion, right? That's why we have a straight line, right? So whenever you have straight line, which means we are going with equal interval of time covered by equal distance, that is called as what? Uniform motion. So this is exactly in uniform motion. Just I have taken 2 points A and E. We have to find out what is the distance covered. For example, I have taken this A, B, C, D, E, this area. What is the distance covered? I have to calculate. This is very simple actually. Distance moved. So what is the distance moved? This is the area. That red color point is called as the distance covered area that we are going to calculate now. So S is equal to area of A, B, C, D, E. Right? That entire area I have to calculate. Now you just draw a parallel line. Now you look at the diagram. This is in rectangle. This is in triangle. So we can easily find out that area, right? So area of rectangle, one formula we know. Area of triangle, the formula we know, right? We just substitute that. That's it. You will get. So S is equal to area of rectangle plus area of triangle. Area of rectangle is nothing but L into B. So L is BC and B is AB, right? So BC and AB multiply that plus of BH, of into B breadth, that is AD, height is DE. AD and DE multiply. When you solve this, you can easily find out what the distance. No sir, is there any other method? Yes, we have direct method, that is called as, this entire portion is called as trapezium. So we have the formula for trapezium formula. So how can we calculate the trapezium? S is equal to area of trapezium, that is A, B, C, D, E, that entire area. How can we calculate that? Is of into sum of parallel sides. That parallel sides should be calculated, right? So this is called sum of parallel sides. Now what we have to do, that we have to take. So sum of parallel side, that should be added. So A, B, this is A, B, this is C, E, right? So these two lines, that's called parallel lines, that should be added. So AB plus CE. Along with that, half into sum of length of parallel sides into distance between parallel sides. What is the distance between parallel sides? That is BC or AD. So anything that we can take, I have taken, that is BC. So into BC. So half into AB plus CE into BC, that is the formula for this entire area. So total distance covered we can calculate by using these two formulas. This will be used in the next case, that is we are going to use equations of motion. Okay, so equations of motion we are going to use this formula, that is nothing but half into sum of the parallel side into distance between the parallel side. Half into sum of the parallel side and distance between the parallel side, so that we can easily find out the area covered by the car. Okay, so this is very important. Using these two formulas we are going to solve equations of motion. Okay, so equations of motion we are going to solve three equations actually. That is V is equal to U plus AT, S is equal to UT plus of AT square, V square is equal to U square plus 2AS. These are the three equations that we are going to derive here. It's very simple actually. That is V is equal to U plus AT, that we have seen in acceleration formula. So V is the final velocity, U is the initial velocity, A is the acceleration, T is time, right? So everything as the definition, that S is the displacement or distance covered, U the same way, the initial velocity, T is time, of A is the acceleration, T is time, right? So first of all we have to take that graph that we have seen in the last session before class, that is x-axis should be taken in time and y-axis, that is velocity. Now we have to plot the point and this diagram should be marked. Now I have to take the point between C, which means A, B, C, D and E, right? So now that initial speed, for example, the starting speed, that is 0 to the particular place, that is O to D, that is initial speed, so that is marked as U. What will be the final speed? Final speed, that is starting from O to C, that is called as final speed, that is V. So initial OD, that is U, final OC, that is V. In the same way, the other side, EA is called as initial speed and EB is called as final speed. It's very simple, right? So OD is initial speed, that is, which means initial velocity, that is U, and OC is final velocity, that is V. In the same way, the other side also, because that parallel side, that's equal, so EA is U and EB is V. Now the x-axis should be taken as time, so the time, no problem, that is OE will be taken as T. So that same way, the DA is also that same parallel line, so that should be taken as T. CB also T, right? So this is the thing that we have to mark in the diagram, right? So in the graph, we have to mark A, B, C, D, E point should be marked. The starting point OD is initial velocity and OC is the final velocity. In the same way, the other side, and the time T. That alone you have to mark, right? That's what I have written here. So here, on another thing that we have to remember, that is AB and DC is equal, right? So the distance between AB and distance between DC is equal. So at the same time, here OE is equal to DA, that is time, that is equal, already I told you, right? So these are the things first you have to write. Okay, so they are key points. Then only we can solve the equation. So let us go to the first equations of motion. That is nothing but A is equal to changing velocity by time. A is nothing but acceleration. We know the formula. Acceleration is equal to changing velocity by time. So changing velocity could be written, that is, whenever there is a change, we have to subtract from final minus initial. The same way here also, final velocity minus initial velocity by time. Right? So what is the final velocity here? For example, starting from O to C is the final velocity. So OC minus initial velocity OD. So OC minus OD divided by OE, that is time. Time is OE, or you can write DA, that you can write. So A is equal to OC minus OD. When you subtract OC minus OD, you will get this point alone, right? So that DC we will get, so DC by T, that is the final value. Now we have to take the T other side. So A, it will become multiplication, then A into T is equal to DC. Now I need to know that DC, right? So DC we have to calculate. So what we have to do it for that? So DC is equal to AB, already we have told you, right? So AB is equal to DC, which means this area is equal to this area, right? So from that we are going to solve that. That is DC is equal to AB. Already we have found DC is equal to AT, right? So all are same. So DC is equal to AB is equal to AT we can write, because AT is equal to DC. Now what I am going to do it now. So DC is equal to AB is equal to AT. Now I need to find out this total value, right? So EB value. So EB is equal to AE plus AB. When you add these two, you will get the final value, right? So EB is called as final velocity, that is V, is equal to AE, we know very well, that is initial velocity, that is U, plus AB, already we have found here, that is AB is equal to AT. So we can write here, that is B is equal to U plus AT. First equation is solved, that is P is equal to U plus AT, that is final velocity is equal to initial velocity plus acceleration into time. Okay, in that we are going to solve the second equation. Area of quadrangle, that is DOEB, right? DOEB. For example, only this area. So in the last class I told you one formula, that is area of quadrangle, that is DOEB. So we have two parts here, right? One is rectangle, another one is triangle. So we have to take area of rectangle plus area of triangle, that is displacement S. So S is equal to area of rectangle. What is the formula? Area of rectangle L into B. So O D into O E plus area of triangle, that is nothing but half into length. Length, that is BA of BH, height, that is AB. That's it. So S is equal to OD. What is the value for OD? That is U into OE, value that is T, plus of DA, value TA, that is again T, into AB, value already we have found here, AB, that is 80, right? So 80. So very simple. S is equal to U into T, UT plus half into A into AT square. Right? That's it. So third equation, the same area of quadrangle, that is DOEB. Right? For that I have told you that is called as area of trapezium. So we can take it as area of trapezium, that we have the formula, that is half into sum of parallel side. Sum of parallel side into distance between parallel sides. Sum of parallel side, that is S is equal to sum of parallel side, that is OD plus EB, right? OD plus EB, then into half into, then into distance between the parallel side. Distance between the parallel side, that is nothing but OE. So S is equal to half into OD plus EB, that is EB, that is B, plus U into OE, that is T. So we know the formula for acceleration, that is A is equal to B minus U by T. So I need to take T, right? So T is equal to B minus U by T. So substitute that, instead of T I can substitute B minus U by T, right? So U minus T by A. So S is equal to 1 by 2 into B plus U, B minus U by A. So all that take this side, 2AS is equal to B plus U, B minus U, right? So V square minus U square. So U square take this side. So 2AS plus U square is equal to V square. The final formula. So it's very simple. That is equations of motion. V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus 2AS, that we have to derive. First we have to take the graph, then the point should be marked, that is A, B, C, D, E. So OD is the initial velocity U, OC is the final velocity V, then OE is T, at the same time DA is also T. So you just take all this value and substitute, and we can find out first equation. Acceleration is change in velocity by time. Change in velocity we know very well. Final velocity minus initial velocity by time. Final velocity, that is we have to calculate OC minus OD divided by OE. So OC minus OD, when you subtract these two, we will get DC. So take this side, AT is equal to DC, then DC is equal to DC is equal to AB is equal to AT. So then you have to find the other side, that is EB is equal to AE plus AB. So you just have the value, that is EB is equal to B, AE is equal to U, AB is equal to AT. substitute and you get the final, that is b is equal to u plus at. The second way, that is area of quadrangle, that is DOEB. S is equal to area of rectangle plus area of triangle, that is L into b plus half BH. Substitute the value, directly you will get this. We have no problem with the second equation. The third one alone, we have small problem with this. What is that? Directly we can't get that. We have to use the other way, that is area of trapezium, that is half into some other parallel side into distance between the parallel side. So half into some other parallel side into distance between OE. So you substitute all that value. So we have to solve, that is b square is equal to u square plus 2as. Unless otherwise we substitute that acceleration value, we can't get. So s is equal to half u v plus u into t. So what we have to do, instead of t we have to substitute v minus u by a. So when you take all this 2 and a other side, it will become 2as is equal to v plus u, v minus u, that is v square minus u square. So I need to get that u square can move the side. So 2as plus u square is equal to v square. That is the final formula. We got it. So these are the three important equations of motion. That is important 5 mark. Without this question, you will not get any question paper. Okay, so it's very important question. Next topic, we are going to discuss centripetal acceleration, centrifugal force. Okay, centripetal acceleration, centrifugal force. This is very simple experiment actually. Just take one small stone and tie with the rope, you just rotate it. Okay, we are just holding the rope and rotating. So what will happen actually, there will be acceleration created. So why the stone is rotating in a particular circular path? It's because motion of a stone in circular path with constant speed and change in the direction. But that stone will be in the constant speed, but the direction alone will be changing, right? So direction will be changing, but speed will not change. Speed will be constant. That is called as centripetal acceleration. So what will happen? Why it's called as centripetal acceleration actually? When that object in the circular motion, so what will happen? The acceleration created on the object will act towards the center, right? So the acceleration will act towards the center. That's why it's called as centripetal acceleration, right? So the force which is created by the acceleration is called as centripetal force. So centripetal acceleration is nothing but acceleration which is created, which means the acceleration will go towards the center. So that's why it's called as centripetal acceleration. And centripetal force, when the acceleration comes towards the center, there will be force created. That force is called as centripetal force. Okay, so what we have to remember in this, why that stone is rotating in a circular path? Because the speed is constant, the direction is changing, so that the acceleration is created in the stone, right? So that is the reason. So acceleration directed inwards, so it's called as centripetal acceleration. Force acting towards the center, that's why it's called as centripetal force. Centrifugal force is just opposite. Centrifugal force, fully force acts away from the center is experienced. Okay, what we are going to do is, we are just rotating the stone, right? Likewise, this is called as centrifugal force. So what will happen here? Force acting away from the center. Force acting away from the center is just opposite to the centripetal force. Centrifugal force is opposite to the centripetal force. So force acting away from the center. So force will be away from the center. What is the example is washing machine. Okay, so these are the final topic, that is centripetal acceleration and centrifugal force.
Freely falling objects and acceleration due to gravity. All objects, when dropped from a height, fall towards the earth. This happens due to the gravitational force exerted by the earth on the object. Suppose you drop simultaneously a small stone and a cotton ball of the same size from a height. Which of the two will reach the ground first? We see that the stone reaches the ground earlier than the cotton ball. So, we may falsely conclude that the heavier objects fall faster than the lighter ones. That is, the acceleration produced in heavier objects is more than in lighter objects. Galileo showed that all bodies, whether light or heavy, fall at the same speed towards the earth. Galileo explained that the lighter bodies fall at a slower rate due to the resistance of the air. Later, Robert Boyle proved this experimentally. He placed a coin and a feather in a long glass tube and evacuated it with the help of a vacuum pump. Robert Boyle observed that when the tube was inverted, both the coin and the feather reached the bottom of the tube at the same time. Thus, he concluded that the acceleration produced in all the freely falling bodies is the same and does not depend upon the mass of the falling body.
Imagine you've got a tennis ball attached to a piece of string, and you start swinging it in circles. Whoa now, watch out for your buddy. Let's take a closer look at the fascinating physics of this simple action. You've probably heard of Newton's second law of motion as it relates to objects moving in a straight line. Turns out, Newton's second law also tells us about the net force on an object as it moves in a circle. When an object moves in a circle, its velocity changes direction. Since the velocity is changing, that means we have an acceleration. And we know from Newton's second law that if we have an acceleration, we have a net force. Now back to our spinning ball. For objects undergoing circular motion, the net force on the object is called the centripetal force. It's a weird-sounding word, but it's Latin for the phrase center seeking. It's named centripetal because the centripetal force always points to the center of the circle. The ball has a tangential velocity, so if you suddenly cut the string, it would fly off in whatever the tangential direction was at the moment you made the cut. But assuming you don't cut the string and you keep swinging the ball's tangential velocity is constantly changing directions. This means the ball is accelerating, and the reason it's accelerating is due to the centripetal force. The centripetal force acting on the ball is constantly directing the ball towards the center of the circle, your hand. This, combined with the ball's velocity, keeps the ball swinging in a circle. The same centripetal force that keeps the tennis ball swinging in a circle also keeps roller coasters on the track as they go through a loop-de-loop. So the next time you're having a blast on a roller coaster, you can thank the centripetal force.
First, look at this activity. Students tie a small piece of stone with a string about 1 meter long. Hold the string tightly in your hand and rotate it. What do you feel? Do you have to apply the force? Does the stone try to pull your hand away? Your hand should exert a continuous force on the stone to maintain the rotation of the stone in the same circle. This force, which is exerted by the hand on pulling stone towards the center, is centripetal force. Hence, when a body moves in a circular path, the force which acts towards the center is called centripetal force. You will also observe that the stone is exerting a force which tries to pull itself away from the center of the circle, that is, away from your hand. This force is the centrifugal force. Similarly, when a body moves in a circular path, the force that acts away from the center is called centrifugal force. While cycling in a bend or a curved path, a cyclist experiences a centripetal force, due to which the cyclist bends inwards. When a bus is moving in the bends, the passengers experience centrifugal force. Due to this force, the passengers bend away from the center of a turn or curve. Students, have you seen a magnet? A magnet exerts force to attract metals like iron, cobalt, and nickel. This pulling, which is exerted by the magnet on the iron, cobalt or nickel, is called magnetic force.